Okay, so when we look at question number 1, it says, find a polynomial f of x of degree 3 that has the indicated zeros and satisfies a given condition, okay? So, I mean, let's kind of work in reverse here. They give us, well, first off, they give us the zeros, -1, 2, and 3. And they also say f of x, I'm sorry, not f of x, f of -2 is 80, okay? So, what I want you to understand is this. If I give you this right here, f of x, just watch, don't write this one down. F of x, whatever that says, x minus 4, x plus 8, x minus 7. If I give you that, you should be very quickly, and if maybe you're still on summer mode, so I don't want to embarrass anybody here, but you should be able to tell me very, very quickly what the zero, first of all, what degree is that? First, second, third, fourth, fifth? Third. Why? Be careful. Everything's to the first power, but it's third degree because how many x's you see there? 3. What are the 3 zeros? 4, -8, and 7. How'd you get that? Opposites, okay? Now what I want you to understand is this. What if I put a 4 or a 5 right in front of this? What would my zeros be? 0. Careful. What would my zeros be? It'd be the same thing. Okay? It'd be the same thing. It's what I plug in for x to make 0. Okay? Since I just put a 5 there, I didn't add an x in there. So now what if I did this? 15, what would my zeros be? Same thing. Now, would those graphs look exactly the same? No, they wouldn't. I mean, if my zeros were 4 and 7 and -8, just so you understand, the first one might look like this. The second one might look like this. They have the same zeros, but they're not the same graph. They're nowhere close to the same graph. If I made this -15, again, it would have the same zeros, but it wouldn't be the same graph, okay? I can have an infinite number of graphs that go through these 3 zeros, okay? So, let's look at this. Our zeros are -1, 2, and 3. We're kind of working backwards. Here, my 0 was 4, so x minus 4 was my factor. -8 was my 0, x plus 8, and so forth. So, when we do this, f of x equals, well, the first 0 is -1, so what's my factor going to be? X what?
1.
X what 1?
Plus 1.
Plus 1. How'd you get plus?
Opposite.
Opposite. Next one is x minus 2, x minus 3. Now, but they give you more information, okay? There's a number sitting out front here, okay? If I make it a 7, we still have those same zeros. If this is a -4, these are still the same zeros, okay? So, there's an infinite number of polynomials that have zeros of -1, 2, and 3. We have some number here. I'm going to label it A. I don't know what it is, okay? Some number. I don't even know if it's positive or it's negative. I really don't know, okay? Now, here's what we got to do, though. I'm plugging in -2 for x. So for each of these x's, I'm going to plug in -2. And when I plug in -2, we're going to get an answer of 80, okay? So when I plug in -2, so just watch for a second here. If I plug in -2 here, and here, and here, and here. Watch carefully. What is f of -2? 80. It is 80. Okay, so I'm going to get rid of those again real quick. So just watch real carefully here, okay? I just wanted you to be able to see that. I plug in -2, and f of -2 is 80. So 80 equals A, plug in -2 plus 1, -2 minus 2, -2 minus 3. Now, I didn't say this explicitly. I'm curious, so what is it we're doing right now? I mean, I'm doing a little bit extra work in order to find out what A is. We said A is some number. I don't know what it is, okay? We got to find out what that number is. So let's clean this up. 80 equals A times -2 plus 1 is -1. -2 minus 2 more is -4. -2 minus 3 more is -5. 80 equals A times -1 times -4 times -5. Just make sure we're all on the same page here. You might still be on summer mode. True or false? -1 times -4 times -5 is going to be a negative answer because they're all negative. Is that the reason? Because why? No, because they are all negative. It's an odd number of negatives. If I had 20 negatives and times them together, you're going to get a positive. Okay? So it's going to be a -20. Divide by -20. A is -4. We're almost done. We got one more thing to do. Plug it in. So So your final answer is f of x equals -4 times x plus 1, x minus 2, x minus 3. So what we did was this, okay? Once you jot all this down, I'll explain it a little more carefully, a little more clearly. If we look at our final answer, our zeros are -1, 2, and 3, just like we said they were. And if I was to plug in -2 for each of these x's, I'm not going to do it right now, but if I plugged in -2 for each of these x's, we'd get an answer of 80, just like they said. Okay? All right, let's look at number 3. Yes, sir.
When you finish, you have to write it out like that with the answer filling in the whole, or filling in A with the whole equation.
I mean, if you wanted to, you could do this. Back there, I don't care. As long as I can tell what the answer is. So, I mean, your final answer should be f of x equals something. I should make that an x now. Okay? Number 3, same type thing. Okay? So we have -4, 3, and 0. And f of x is, or f of 2 is -36. Okay, so it's third degree. Our zeros are -4, 3, and 0. So we have f of x equals a, some number, we don't know what it is. Okay? -4 is a 0, so x plus 4 is a factor. 3 is a 0, so x minus 3 is a factor. If 0 is a 0, what do I put down? Well, I gotta put something. X what? Plus 0 or x minus 0?
Either.
Doesn't matter. What's x plus 0?
Zero.
Not 0.
Oh, X.
What's x minus 0? So we could just say x. Okay. Okay, we got to find out what a is. Okay. So we're going to plug in. Last time we plugged in -2. What are we going to plug in this time?
Positive.
Plug in +2 for all the x's. If I plug in +2 right here, we have f of 2. And what is f of 2? -36. What do I plug in for a? Sort of a trick question. Nothing. That's what we're trying to find out. What is a? So a times 2 plus 4, 2 minus 3, times 2. We just plugged in 2 for all the x's. Clean it up. -36 equals a times 6 times -1 times 2. -1 times 6 times 2 is -12. Divide by -12. A is 3. So your final answer is 3. And there's nothing wrong with this. I'd accept that full credit. Generally, you would have put the monomial first, the x. I would have put this. You normally would put f of x equals 3x times x plus 4. I'm not going to mark you wrong. It's just the one term x, as opposed to the two. Usually put the monomials first, then the binomials. It's just the way you do it normally. Number 5. Okay, one more of these. So we have -2i, +2i, and 3.
Are we
F1.
using I as like imaginary?
Definitely imaginary. So this is third degree. Just want to make sure we understand. How many times does this graph, whatever this graph looks like, touch the x-axis? It's third degree. Does it touch it 3 times? Only once. Why? The other two are imaginary, okay? So it touches at 3. That's the only place that it touches the x-axis at 3, okay? So f of x equals a times, if -2i is a 0, x plus 2i is a factor. If 2i is a 0, x minus 2i is a factor. And if 3 is a 0, x minus 3 is a factor. Now this one's a little bit different. I would really encourage you simplify this one first. Unlike over here, we didn't. We didn't simplify, we just plugged in the number. And the reason is because we have imaginary numbers here, okay? So it would be to your benefit to simplify this. Which ones do you think we should multiply out first? The first and the second and the third, or the first and third? Which ones do you think we probably should do? Which ones? It doesn't matter, but I would do the first two, because they're the ones that are imaginary. Now, and again, we're covering a lot of stuff from Algebra 2, they might have forgotten. We would FOIL this out, but these are what are called conjugates, in case you forgot, conjugates. When you do conjugates, you don't have to do all of FOIL. You just have to do your first and your last, because your outers and inners cancel. If you want, you can. I mean, I'll do all of it here just for the heck of it. Just watch. First is x times x is x squared. My outers, x times negative 2i is negative 2xi. My inners are positive 2xi. Those are going to cancel. Okay? So I'm just going to cross those out. Then do your last. 2i times negative 2i is negative 4i squared. And we can clean this up a little bit. It looks like we have an imaginary number here. Do you guys remember what first off, what's I? And don't just say it's imaginary. Do you guys remember what I is? It's a number.
Is it negative 1?
Close. You're leaving something out. It's not negative 1, you're leaving something out. Negative 1's real. Square root of negative 1. So what's I squared?
You wrote this down.
Yes,
So we did.
Negative 1, just negative 1. Remember, if I square this, I square that, and these things cancel. I squared is negative 1.
Oh, then it was I3, that was like.
Yep.
Okay.
We don't have to worry about that right now, though. So I squared is negative 1, so what does this term turn into?
Positive 4.
X squared plus 4. Now, we could FOIL that out now too if we wanted to. I'm not going to. Why did we FOIL out the thing previously? Get rid of the imaginary stuff, okay? There's no imaginary stuff there now. I mean, if you want to FOIL it out, go ahead. I'm not gonna, okay? So this time we're gonna plug in what? First time we plugged in negative 2, then we plugged in positive 2. This time we're gonna plug in 1.
Now on the test, what are the chances that we are not going to get the I squared and just making a negative 1?
Say that one more time.
Like, what if we get I to the first power, I to the third power?
You won't.
Are we going to get any of those things?
You're not gonna on this test, no. Okay? I mean, they purposely did this so you could get rid of the I's. And that's what I would do on the test. If I give you one like this, you'll be able, when you FOIL it out, your I's will be gone. If they're not, you made a mistake. Okay? So we plug in 1 for each of the x's, and f of 1 is 20. So 20 equals a times 1 squared plus 4, 1 minus 3. We just plug in 1 for all the x's. Again, I plug in 1 here, and f of 1 is 20. So 20 equals a times 1 squared is 1 plus 4 is 5. 1 minus 3 is negative 2. I'm going to skip a step here. Is everybody okay with that? I know 2 times negative 5. Negative 2 times 5 is negative 10. So I just divide by negative 10. And we're almost done. Plug in negative 2. So again, what we're doing is this. We're creating the polynomial, finding the polynomial that has zeros here, and then when you plug in 1, you get 20 for an answer. Two more for today. I want to give you guys time to finish up working on your homework from yesterday if you haven't already got it done. I think most of you got most of it done, if not all of it. Okay, these sound confusing. 7's actually easy, okay? Easier. I didn't say easy, easier. I did say easy. I meant easier. Find a polynomial f of x. That's what we were just doing, finding a polynomial with degree 4 and lead coefficient 1 such that both negative 4 and 3 are zeros of multiplicity 2, and then sketch the graph. Okay? This one's going to be a real simple one, okay? Just want to make sure you guys understand what it means here. This is the fancy way of saying something we were just doing. It says lead coefficient is 1. It says degree is 4, lead coefficient is 1.
So the first number has the leading
It's not nothing, it's 1.
Yeah, X.
So what does that mean? We've been doing it up there on the board.
X minus 1?
No, the lead coefficient. Okay, I just want to make
Is
sure.
it
Huh?
A? Is it
A is 1. We know what A is. It's 1. How do we know that? It says so. A is 1. The lead this number right here is 1 on this problem. That's nice, okay? So, they tell you that -4 and 3 are both zeros of multiplicity 2. Okay, let's put that down. Multiplicity 2. Okay, which makes sense because it's 4th degree. Okay, it's 4th degree. So that means your zeros, I'm going to say it kind of redundant here, are -4, multiplicity 2, which means -4 and -4, and +3, +3. 4th degree. How many places does it touch the x-axis? Only 2. Where? At -4 and +3. Okay? So, f of x equals a, well, we know a is 1. If you want to put 1, go ahead, or just don't put anything. X minus 4. I'm sorry, -4 is my 0, so x plus 4. But it's multiplicity 2. You guys remember how that alters your equation a little bit? You put a 2 here. Okay? And then 3 is a 0, so x minus 3 multiplicity 2. Because what it would be is this. Here's the long way. Just watch for a second here. The long answer would have been x plus 4 squared is x plus 4. X minus 3 squared is x minus 3, x minus 3. So instead of saying my zeros are -4 and -4 and +3 and +3, -4, -4 means there's 2 -4s. Multiplicity of 2 means there's 2 of them. If it was multiplicity 3, it'd been to the 3rd power. Okay? And you guys remember from algebra 2? What happens at -4? It's raised to the power of 2. What happens to the graph? It bounces off. It's either above and bounces off, or it's below and bounces back down. It bounces. It bounces at both. Is it bouncing because it has a power? I'm leaving out a word, not just a power. An even power. It's got to be an even power. Okay? So, let's graph this thing. We have -4 and +3. We put dots there. Okay? One more thing, it's a lot of information we have to remember from algebra 2 in this problem, okay? This is 4th degree. Remember, 4th degrees generally look like a parabola, okay? Either a parabola opening up or a parabola opening down. For example, if I give you this right here, that would be like 6th degree, 8th degree, 10th degree. It'd have to be an even degree because it generally looks like, other than this part right here in the middle, if I could cover that up a little better, had a bigger piece of paper, wouldn't that generally look like a parabola for the most part? They went like this. That would be even degree. That'd be like 8th degree, 10th degree, 12th degree, something like that. Would this be even degree? No, that doesn't look like parabola. Parabola, they both go up or they both go down. If it's odd degree, one goes up, one goes down, okay? So this thing is generally, since it's 4th degree, it's going to look sort of like a parabola, okay? Is the parabola generally opening up or parabola opening down? Up, why? What's not negative? What's the lead coefficient? +1. So it's going to open up. So it's going to go like this. And Meerkat already said what happens at -4. What happens there? Bounces. It goes up forever? How do you know it has to go back down?
There's another touch.
Right, it's got to hit that other point. It goes up how far? Some. I don't really care. Up some. Goes back down. Hits 3, then what? Bounces. Looks sort of like a W. W-ish. One more than we're done for today. I think number 9 is going to be easier or tougher than the one we just did? Why? I agree, it's a little tougher. What was nice about number 7?
Gave us A.
Yeah, they don't tell us what A is, okay? So we got to find out what A is again. Polynomial of degree 6, 0 and 3 are zeros of multiplicity 3. So 0, multiplicity of 3, and 3, multiplicity of 3. And f of 2 is -24. Okay, go with the polynomial and then sketch it. So this basically starts off like what we were just doing a few minutes ago, okay, at the beginning of the worksheet. So f of x equals, we don't know what a is, so we gotta put down a, times, if 0 is a 0, this is what Alexis answered a few minutes ago, if 0 is a 0, we're just gonna put x, but multiplicity of 3, so x cubed, x to the third. And 3 is a 0, x minus 3, multiplicity of 3 to the third. Okay, we got to use this bit of information. F of 2 is negative 24. Plug in 2 for the x's. If I plug in 2 here, f of 2 is negative 24. A, we're trying to find out. Plug in 2 for the x's. So 2 to the third, 2 minus 3 to the third. Just plugged in 2 for all the x's. 2 to the third, be careful, it's not 6. It's 2 times 2 times 2, which is 8. 2 minus 3 is negative 1 to the third. Negative 1 times negative 1 times negative 1 is negative 1. 8 times negative 1 is negative 8. Divide negative 8, divide negative 8. A is 3. Okay, we plot, do a very quick rough graph. Our zeros are 0 and 3. Now, you gotta be careful on this one. What does this look like? Does this look sort of like a parabola, or is it like those S-shaped curves? You gotta be careful on this. Huh?
It's a parabola.
Why?
Because 3 is a, and that's minus 2.
Well, no, you're mixing steps here, okay? First off, this right here. Is that even or odd degree? Odd, why? One goes up, one goes down, okay? That's an odd degree, okay? Is this polynomial, what degree is this right here? You gotta be careful on this. 6th. A lot of students say, oh, it's odd, 3. This is 3.